Okay, so welcome back from the break, everyone. This is the 101 session. One thing that I never know, this 101, 201 metaphor, I'm a US American, so I understand it because it was used in our universities for labeling courses, but does it make sense to people? This is a little more beginner, the other one's a little more advanced. Good, yeah, okay. That said, we're going to get into a fair amount of depth here, so it's not going to be super superficial. Our intent is to hopefully show you a bunch of things, give you some familiarity with them. We may go through a lot of things too fast for you to come away with feeling like you really understand them, but you have the slides and the links and you'll have tried things, and hopefully you'll get a whole bunch of little seeds planted and information so that you can then go off and go into more depth in the future. Because we only have a limited amount of time. I do want to mention, did everybody get their bag out front? No. If you didn't get one of these, in between here and the glass doors out there is a table on the right that has your name on it. You get a t-shirt, some stickers and things probably in there. So just a little goodie bag to welcome you and say thank you for coming. I don't want you to leave without that. Okay, next thing. Do you mind coming a little bit closer? You should still all spread out, and you definitely are going to want to be at a table with power because we're going to be doing stuff on our laptop, and it will drain your battery. So while you're doing that, coming closer, but also spread out a little bit and make sure you have power, those things, to talk about what we're going to do. So just to cover, we're going to have kind of two sessions. We'll have a morning session, we'll go through a bunch of stuff, we'll have lunch, and then an afternoon session. And then we're going to end the day with a meet and greet with other people who are current contributors from the different SIGs. So as we're going through the day, if you get questions or you're starting to get a little bit more curious about a particular thing, or you've come explicitly wanting to know about scheduling or scalability or something like that, you'll get a chance to hopefully meet some of those people a little bit face to face. If nothing else, say hi. I'm new, I went to the contributor workshop, I'm interested in your SIG. And that's a great starting point. So morning, we're gonna go a little bit more into repository and code tour. And then we'll talk about the dev environment. And if you look at this, you actually will see in there, dev environment is on there multiple places. So early on, in just a few minutes, I'm going to talk about the dev environment, and hopefully you all can start poking at getting your dev environments set up. Worst case, you all have 10 gigabytes worth of stuff to download to get your dev environment set up, and you're going to crater the Wi-Fi for us all. Hopefully that won't be the case, but we'll iteratively work through it, and we'll have a few checkpoints, and we'll have some people floating around the room. So if you're having trouble, wave your hand here or there, or try and catch some of the people who are volunteers floating around, and they can help you work through. The other thing, leverage the people at your tables too. So you may have gotten stuck on something, somebody else may have made some progress. This isn't just me up here, but we can do sort of peer tutoring and learn from each other as well in that. Okay, so then we'll go a little more into SIGs, but specifically how those tie into the way we use GitHub. And then because this session is about people new to open source, we'll talk about a little bit of open source generalities, but then bring that back into how we do pull requests in Kubernetes, talk about the bots that you'll interact with doing pull requests. We're going to do a little GitHub playground exercise. Again, double check on how you're making progress on getting your dev environment set up. Then we'll have the break at lunch, and that may also provide us some time to do some downloading and tinkering on the machines depending on where you are. Afternoon, we'll start out with the final dev environment check, and hopefully you'll all be up to the point to be able to actually go into the build systems. And we'll try and make a few things. We'll do a simple little tweak to the kubectl code, try and build that and run it and see that you've successfully built your customized kubectl. We'll talk about testing a bit and then kind of come back around to SIGs minimally to talk about engagement and where you might be able to get your first ideas for getting engaged, and we'll carry that into the SIG face-to-face in the evening. So to back up maybe one step, I should probably introduce myself. So I'm Tim Pepper. I've been working on Kubernetes for 2 years and cloud for about 4 years. And before that, I swore I was never going to work on cloud. I thought it was this really fluffy, ambiguous thing. And I've been doing lower level system software for a long time. I've been in industry about 20 years, and I've specialized in open source. So I've been doing open source primarily for all of my career, 20 years. So I have a fair amount of experience in system software and open source, but cloud is also a little bit new to me. So I feel like maybe I can relate to what some of you all may be going through as you orient to Kubernetes, because it's a big, complex topic. So know that you can do it. It's going to take time to learn. I'm proof that it's possible to get into it, and it can be fun too. So I hope you all have a positive experience. Okay, so first of all, before we get into a code repository tour, I wanted to do just like a basic level set on what is Kubernetes. And I want to do like a few kind of show of hands. So my background is system software development. I've done things in the Linux kernel and device drivers and all up the stack from there at this point. But who here is a developer somewhere, like in the stack? We got mostly developers. What are some other personas out there? What about, nobody at that table raise their hand. What do you do? Okay, developer, product owner, architect. We have project managers in the room, yeah? Anything else?
Marketing.
We have somebody from marketing here, yeah. Cloud advocate, solution architect, very good role. Do we have any DevOps people? Yeah?
I hope all DevOps people raised their hand when you said developers.
Yeah, who didn't raise their hand as a DevOps person for developers, yeah. Very good point. Full stack engineer, I don't know what that means exactly, but there's one hand there, yeah. So who has familiarity with containers, first of all? Cool. So you all know Docker. Who has written Go code before? A mix, okay. What other languages? C? C++? Java? Python? Yeah, okay. So we got a big mix. Fortran. We gotta go through all of them, but yeah. So I just want to kind of get a general sense of where people are coming from. So based on where I saw people raising their hands, y'all are ready for this. Who has seen this picture before, the Kubernetes architecture? Got a few. So at its most basic, people talk about Kubernetes being a container orchestrator, but that's the abstract. What it does concretely, you have a control plane, so that's the left side of the picture, and then that control plane interacts with users who are trying to, ultimately, today, what it would be is run a container probably, but more abstract, a user of the cluster wants to run something for a workload. And that's written or described in some type of YAML. You get that handed over to the control plane. It figures out how to get that off onto, oh, and this is an old slide. I grabbed a bad picture, and this is, hey, Jonas, this is on the docs website right now. Can you open an issue to take the minions off of this? We used to call them master nodes or minion nodes, kind of changing that over to control plane and worker nodes. But you ask the cluster to run some work for you, it finds a node that's able to satisfy your resource needs, gets your workload running there. Within all of that, within the control plane, you have an API server that you interact with, and then you have these controller manager entities, a scheduler, there's etcd for a key value store to persist data related to the state of the cluster. And then on each of those worker nodes, you have a kubelet and a kube proxy. And then depending on what cloud you're running on, you may be running just bare metal, or you may be running on something for a virtualized environment, the cloud picture. all of these things get mapped onto the specific cloud that you're using. Also, as we go along, feel free to raise your hand if you have questions at any point, okay? And my volunteers, stand up for a second. Sylvia back, Arnaud. These people also, as they're floating around, wave at them, grab them if you've got a question you're struggling on something. And thank you very much for coming and helping today. Okay, so code repo. Oh, one of the questions I didn't ask. So this is the fourth time I've done roughly this workshop, and sometimes we have people who are new to GitHub. Who here does not have a GitHub account? Don't be shy, because we could work through this and get going as soon as possible. Okay, everybody's got a GitHub account. Cool? All right. So if you're on github.com/Kubernetes, as Gwen was talking about earlier, that's the org. And below that, github.com/Kubernetes/Kubernetes is the core Kubernetes repository. And I just realized I need to switch over my graphics so that I get the speaker notes. Give me just one moment here. Because I have a whole bunch of little reminders of things that I want to say besides what are in these slides. Okay, and if I put this back in presentation, we have the wrong ones. All right, okay. Oh, and now that I've done that, the whole point I was doing that was actually because I want to actually open up a browser here. All right, so if I go to Kubernetes, and all right. I actually probably should have kept it mirrored for this part. Okay, so let's make this a little bit bigger. There is a ton of stuff here. And as a newcomer, I think it's particularly daunting because you have all of these things that you scroll through. And eventually, if you actually get down to it, GitHub is nicely showing you a README. And there it's trying to be sort of basic orientation sort of stuff. But it's very basic. It says how to start, here's some links, and start developing, here's some commands that you can run, and they probably don't run initially because there's all sorts of setup you have to do. But then what is all of this stuff? So I wanted to talk about just a couple key parts of it here. The first couple are going to be build-related things. So build directory, obviously build-related. Less obvious, hack. Inside the hack directory are a whole bunch of little shell scripts. And a lot of the commands that we'll run today or that you'll fairly quickly get into running are going to be things maybe that source some of these shell commands or invoke them from different places. So you might run into some errors in this code here or there, have to figure out. And this is one of the first complexities. It's a very big project that does a lot of different things. And as a newcomer, you might just run your very first command and have an error message, and it's going to be referring to something in here in some random script hack something, and it may not make sense. Don't worry about it too much. The name might imply like this is the place where the hackers are and this is the super skilled people. No, it's all of the standard little bits of scripty things, and if you're having trouble, it's a common thing because a lot of the code here is relatively old. And my personal sort of heuristic is when I'm writing bash code and I have to write a function or use an array, I need to stop using bash. I'm ready for a different language, maybe Python or something else for a better scripting language. And the project as a whole needs to start making some transitions like that probably. There's a bunch of crufty old little scripting things that you all are going to run into, and it's going to be rough edges. So I apologize in advance, but you'll be able to work through it, and over time, hopefully, you'll be able to even contribute to making these things better. All right, the other couple ones I want to talk about. So about half the room said they were familiar with Go or had done a little bit of basic Go. In this command directory is the standard CLI things. So we'll talk, for example, about kubectl. If you go and you look at kubectl in the command subdirectory, if you're thinking, well, kubectl is the binary that I use to control a Kubernetes cluster, you might navigate down in here and see kubectl.go and think, this is going to be the Go source code for kubectl. You open it up and find that this is 55 lines, and it's just this, a bunch of imports and a main, and it just does basically one thing. It runs the kubectl command right here. So you're going to see the same pattern in all of the things in the command directory, and that's because, generally speaking, things are set up in a way so that there's importable, reusable code elsewhere in the project. All of the CLIs are just the little bit of command line wrapping to deal with parsing options and getting them off into using whatever uses that bit of code. If you want the actual code that's behind kubectl or kubelet or any of the other things, you potentially have two places to start. The first one would be package, and the second one is the poorly named staging. This is a huge point of complexity for new people showing up. The core code of what is Kubernetes is mostly split between these two directories, package and staging. If it's reused code, it probably lives in staging, because staging is in sort of that DevOps mindset. You stage things that you're going to publish somewhere, right? So things that are going to be reused or imported from somewhere need to be available in the Golang standard sorts of ways, and needs certain versioning, and a staging publication step happens there. So staging, think of it as the core stuff that gets published for reuse. And we can actually go in just briefly and look. If we go in package, kubectl is in package. And here you start seeing a whole bunch of actual code. So there's a ton of different subdirectories. So if you're going to do a kubectl apply, the associated code for that is in the kubectl apply subdirectory. And there's tons and tons of code. And depending on what it is you're looking for, these are the types of places that you would go down in the source tree. Another big area of the code, and again related to things that you publish or export for reuse, is APIs. Now, if you're at the top level directory, the very first thing that you have is API. So this is the top of the KK repository. Oh, and I don't know if I've said that or if Gwen said it. GitHub.com/Kubernetes/Kubernetes, we often refer to as KK for short. So I'm in KK here. Very first directory, API. Kubernetes has a bunch of APIs. You go in here, but this is a kind of short list. And it turns out that this is older APIs tending towards deprecated. Where most of the APIs actually are is, again, under staging. And slightly convoluted, staging, source, Kates.io, API. And these, a much bigger list of things. And it actually has a README and details on the things there. So potentially, depending on what you're working on, you might be looking to change or extend an API. This is going to be where the code is that you're looking to do that. A next important area, so I showed that diagram of the architecture. Question, yeah?
So
API and APIs, yeah. So again, one of the confusing things, there's a lot of layers or generations across time, but APIs also deprecated or outward going stuff. So in the architecture diagram, I talked about the control plane bits and the components of Kubernetes that run on a worker node, but there was just sort of a cloud also, because that's running on a particular cloud. But you can't just completely abstract that away. If you're wanting to set up a cluster to run, and all of us as engineers, developers, if we're going to write code, who's going to test their code? Oh, that makes me sad. Hopefully everybody raises their hand, but that actually probably was representative reality. We just push, right? DevOps, GitOps, yeah, it'll totally get tested. It'll work in production. If you're wanting to set up a cluster to test your code, this is probably the second difficult point that I see people struggling with as they approach the project. First, like, where's the code? Okay, and building it. But now that I have it built, how do I run my thing? Well, pretty quickly, you need a cluster, and you have to set up and administer a cluster, things like that. You have to pick what cloud you're going to run it on. The first thing that you might run into, especially if you look at the existing test CI that's out there, you are going to see from KK this directory called cluster. Or you may see this come up in conversations on Slack or mailing lists or Zoom meetings where basically everybody's like, oh, that's a bug in cluster code, and yeah, we just need that to go away. There's a common theme in conversations that the cluster directory needs to go away. This is what I think of as mostly deprecated cluster administration scripts for bring up, but still actively used, not well maintained, and things are starting to go off in a different direction. If you're at the conference this week and you see talks about Cluster API is bringing a new, better declarative way of managing clusters, and it's going to ripple into all of the peripheral tools, including the things we use as developers to make a quick little dev cluster for ourselves to run and do code. But today, there's a lot of stuff in this cluster directory. Another one you may, as a developer, want to go look at is docs, because like we all the time, like it's either Stack Overflow or Google search or whatever, trying to find like how do I do this thing. If you go into the docs directory, just kidding, there's nothing here. Again, this is a sort of deprecated-ish area. The place for that is actually on the Kubernetes org on GitHub, the website repo. All the documentation's here. It's there's a kind of a content management system. Things are versioned so that if you land on the official Kubernetes website and you click on docs, there's like a drop down. You can get the docs for 1.11 or 1.14 depending on what you need. So that's outgrown the core repo. And this is a good point to kind of mention. Gwen talked about there being the core Kubernetes repository, but things are starting to scatter to the wind. So website's a first example of that. Another one is if I'm on KK and you think, again, like, hey, I should test my code, and I look through here and, oh, there's a directory test. There is stuff in here, but this is the test cases, and if you're wanting to run tests or you're reacting to a test failure in CI, you may have actually needed to be looking at a completely different repo, the Kubernetes test infra repo. So as a newcomer, some point you're going to get beyond just the KK core repository, and the first ones you probably bump into are the website and test infrastructure. And this is just representative, again, of the kind of monolithic repository, how that is splitting out. And it's going to happen more and more over time. There's been kind of a discussion of whether Kubernetes, if you make an analogy to operating systems, and people say Linux is the sort of the standard Unix now, Kubernetes is becoming the standard cloud abstraction layer, the POSIX of the cloud, something like that, the Linux of the cloud. Linux, you could be talking about a distribution or a kernel. And there's this idea that Kubernetes should start to make that differentiation. KK is kind of the kernel, but you still have a huge distribution of other things around it, some of which are Kubernetes projects or sub-repos themselves, but some of them are completely different. All of your networking or storage related things or your cloud provider things, those are all peripheral. Or anything that you might hear about at the conference here, like out into Envoy and Istio even, that far away, you may use these things, but they're not Kubernetes itself. So you'll have to navigate and understand which of these things live where. All right, so that was basic, super quick discussion of what's where. Now for the really tricky part. If you are going to build Kubernetes, you need a fairly beefy development environment. So you need a lot of RAM, a lot of disk, and a lot of CPU. And what is a lot? It varies, but today you probably need about 6 gigabytes of RAM dedicated to the thing that's going to be building. And I'll get into that in a little bit more detail, but that thing often is a virtual machine. And there's different settings that you have to deal with that are specific to your environment to make sure that you allocate enough resources. A lot of CPU, so I dedicate 6 cores to my Docker runtime on my laptop, and I think I dedicate 10 to my Linux VM, so just as an example of how much you might want. And I get okay builds. And on disk, you're going to need tens of gigabytes of disk. So if you start out thinking, I'll just do this in Linux so it's easy, and you have a little Linux virtual machine perhaps, and it's only got a few CPU cores and a few gigs of RAM and 10 or 20 gigs of storage, you will run out of space almost instantly. So my Linux virtual machine, I give it like 100 gigs of storage. And I think, I'm just gonna, so at the top of my screen here, I've got the little Docker icon, barely perceptible up there. And if I go into my advanced settings, this is hiding it. I've given Docker on my Mac 6 CPUs, 6 gigs of RAM, and a gig of swap also. So just sort of baseline, if you have things really dialed down or constrained, these are the sort of numbers you might need to get things happy enough to run. Now, I've mentioned Linux. I have Linux in a VM on my Mac. It is possible to build in Linux Mac, and I hear Windows. Luamir makes a face. Who here, so show of hands, who's planning to do this all straight in Linux? Linux on bare metal. So Linux is what the OS is on your laptop. 2. Who has a Mac? And who has Windows? No Windows people, yes. Well, you're sitting next to the resident expert, so. All right, so of the Mac users, who intends to use Mac straight or Linux as a VM? So Linux VM on Mac? Okay, and just Mac straight. Okay. For most of what we're going to do today, Mac straight, I think, is a reasonable, good starting point. There will be a few things in the afternoon that I show where to actually run them, you need to be on Linux. Kubernetes historically was an orchestrator of containers on Linux, very specifically. So the control plane needed to run on Linux, and the worker nodes need to be Linux. This is broadening out, but there are certain things that you simply can't do on Mac because it just wasn't designed to do that yet. I mean, maybe in the future if Mac becomes a server operating system again. I don't know. Docker for Mac makes this fairly easy. Again, you probably want to make sure that it has like 6 gigs of RAM. The default when you install is less than that, and you will not be able to build because of that. You'll, specifically when we get to the point of building, if you see link time build failures, it's probably because you've run out of memory and need to tweak the settings and the configuration for your Docker. Golang. Who has Go installed already? Cool, about half and half. Who has Docker installed already? Similar, okay. And for Go specifically, you'll want version 1.12. The specific subversion I don't believe matters today, but there are a few things there that will depend on 1.12. We're going to assume that you have GitHub accounts, which everybody seemed to say, and you'll want an SSH key configured, I think, because we're going to do some actual GitHub workflows, so you'll want to be able to push things. And then you'll want a fork of Kubernetes. Who here has not done that part yet? Okay, perfect. So the next thing, if you go, so this is a picture of github.com/Kubernetes/Kubernetes. In the top right, there's a little button to fork. And what this does is it sets up a Kubernetes repository under your account. And that enables you to make code changes and push commits to branches of your own, and then you can do a pull request against the official Kubernetes. Then the next set of things, and does everybody in the room have the slides? Who does not have the slides? Oh, okay. So if you don't have the slides, you might want to take a picture of this screen, or Jonas?
So I posted the slides in the Contributor Summit channel on Slack, and so you can find them there, or in the email that we sent out last week as well. If you still can't find it, let me know, and I'll send you a link.
Definitely get a hold of the slides, at least eventually, but today, this one slide may come in handy because these are the things that you're going to want to work through. So a fast way to do it might be just to take a picture of it right now, and then you can refer back to it. So to cover what you're going to want to do, a first key thing to be aware of, as a developer, you may have some place where you put your code. So historically, I did Linux kernel work, and the kernel used to always be under user source Linux. So user source is where I've always put my code. But everybody has their own preferences for where they put their code. And Kubernetes is particular on a few fronts where it may want, the build systems or the deploy scripts or things like that, may have some built-in assumptions that it is in a canonical place. And the canonical place is under your Go path, the source subdirectory kates.io/Kubernetes, or whatever other project is there. So instead of the GitHub org, github.com/Kubernetes, it needs to be under source kates.io Kubernetes. So if you have a fork and you create this directory and CD into it, you can clone your repository, and you CD into that directory once it's cloned. And another canonical thing that you should do as you're setting up your environment is to set up the official Kubernetes repository as an upstream repository, or as a remote repository, and call it upstream. That way when somebody says, hey, are you in sync with upstream, or have you fetched upstream, it literally means that. You have a remote repository and you're fetching from the official upstream Kubernetes. And then the next thing you do is actually fetch that upstream. And if you do this right now, the two are basically going to be the same because you've taken the official upstream, you've forked it, you've pulled your fork, and you've pulled the upstream. But this just allows easier, cleaner GitHub workflows. So show of hands, who's familiar with that sort of workflow with having your fork on GitHub and an upstream repository? Or a couple? And who is it definitely new for? Okay. So for the new folks, this is going to be a bit of a challenge at first, potentially, but this will teach you how to interact well with pretty much anything else on GitHub and do PRs, because this is kind of a standard practice at this point. And feel free to ask. On any of these Git commands, who here considers themselves a Git expert? You're lying. There's no such thing. I didn't raise my hand. I don't know anybody who, even people who've been using Git since the first week it was released, who hasn't on occasion totally screwed up something in their Git repository and had to figure out how to fix it up. Git can be really overwhelming for a newcomer to source control versioning. So if you get into trouble, pause, raise your hand, ask for help. There's almost nothing that can't be undone. A couple years ago, I'm an amateur triathlete, and I was about to go out of town for a triathlon, and I was like banging on the keyboard trying to get something done so I could leave town for the week. And I was like thinking about my race and thinking about work and just kind of distracted, and I had finished my work for the week, and I wanted to push it somewhere so it would be safe in case my house burned down or something, and I messed up my Git config, and I lost like the entire week's work of work because I hadn't been doing a good job of source control versioning. And I paused, and I asked somebody who's sort of on my list of Git experts, even though the Git experts don't exist. And in a couple minutes, they'd walk me through a few things, and we found all of my work. It was all still sitting there in Git. So just know that even if you have that sort of panic moment where after today, you're working on something and you think you've lost all of your things, you probably haven't. Pause and look for a helper. Okay, so this is going to be the goal for all of you to get through by this afternoon. It will take some time depending on where you are. And then the second slide is, this will be one where don't try and take a picture of this and copy it, but hop on Slack or look for the email and just copy paste these commands. The first couple of these I think would be good ones to run. Yeah, I guess so. Go ahead and do these. If you get through the other stuff, try and do these. What this will do is pre-populate a few Docker containers on your laptop that we'll be using later in the afternoon. And instead of, at the point that you run the command, it pulling these containers from the internet, we've got a little box here that we've put on the network. And when you do these Docker pulls, it'll pull the images from this box here in the room, and it will be fast. So it'll save us time later in the day. Not everybody will potentially get to this point, but hopefully you can. Okay, so back up couple slides. So as we're talking, if you can all be making sure, if you don't have Docker for Mac or for your OS installed, get that installed. If you don't have Go installed, get Go and install it. And if you're having trouble on any of that, ask your table mates and raise your hand. And I'm going to pause right here. Is there anybody who feels like daunted by that or needs a little more detail on what to do? Don't be shy, because this is like the chance. We've got like 2.5 hours before you need it, so now's the time to start getting the ball rolling. Anybody? Yeah.
Question. I see some Bazel build files there, right? Do we need to install Bazel as well?
So the question is Bazel. I deliberately skipped over Bazel in that in the little bit of code walkthrough, but there were Bazel files in there. Bazel's a build system. I'll talk about Bazel a little bit later, but you don't need to think about Bazel or install it at all today. All right, so be making sure you get your Docker and Go working or installed. Your goal would be, if you're sitting in the KK repository, if you just type make, it should work. That probably won't be the case, but try to get to where you can run make and have worked through at least some initial questions. And if you're more stumped, I'll be checking in a bit as we go, and we'll try to get everybody on the same page to be able to make in the afternoon. All right. So while you all are doing that in parallel, I want to talk a little bit more about SIGs and specifically labels and issues. So Gwen talked a little bit about humans. Like, SIGs are how we organize humans. And as a community, we interact with each other, and we do that on a human basis, but we also do it with automation. And the way that we accomplish that is through labels. I've got to get my mouse back here. So on average, at any moment in the KK repository, there's about 2,000 open issues. And there's also about 2,000 contributors in the community. So how do you map these 2,000 humans to the 2,000 issues and make sure that we're actually making forward progress? The first one is just to add a SIG label to an issue. I did a look, and there were about 300 of those 2,000 issues that were SIG storage related. There were 50 that were in SIG release. There were 20 that were SIG Azure. At that point, it whittles it down a bunch. The people who are working on Azure, they know there are 20 issues to look at, and at a human level, that becomes much more scalable or consumable, realizable. So what this looks like, if you're on GitHub, GitHub has labels. Across all of our projects, though, we have a kind of standardized set of labels and standardized colors. There's a whole set of automation that makes this stuff work, but it makes sure that you get a consistent label experience. Somebody doesn't accidentally mistype approved as approve or SIG Azure as SIG Jure, something like that, and you get this weird proliferation and inconsistencies. So if you look at things here, you'll get the impression of this is just a normal GitHub workflow, if you're familiar with that, but we've put some effort into trying to make sure that there's consistency because there's just so much going on. It would be easy for it to just kind of all flake every which way. And another thing that you can do, if you mouse hover over a given label, it should pop up with a little tooltip describing to you what that label is meant to mean. So gathering all the labels can sort of feel like playing Pokemon if you've played Pokemon. There's like a ton of different ones, and it's even a point of contention. Every now and then somebody will be like, hey, we need to add a label for foo, and everybody's like, oh no, not more labels. So there's sort of an effort to reduce the labels and try to have more commonality and keep the set smaller so that it's not so overwhelming and there's not a new one that comes out every day. We also have a set of requirements, and this is the first time on any of the slides that you'll have seen this thing called Kate's CI robot. When you're interacting with Kubernetes on GitHub, there is a bunch of automation that happens, and there's a robot who will talk to you on your GitHub issues and PRs. And the first thing that you're probably likely to see with it, because as you come to a new project, quite likely before you make a first pull request, the first thing you notice is a bug somewhere, and you file an issue for that. And immediately the robot's going to say, hey, you are required to add some labels to your issue. And the first two are kind and SIG. So the SIG I talked about, you need to do some first order pass of saying like, hey, this is a bug in storage or networking or something. Apply the SIG label for that. And then kind. The first couple of kinds that you'll see typically are bug or feature. Just that's the kind of level of types of things there. And again, this allows people to do just some initial triaging of what's there in this huge 2,000 open issue set. So the way you do this, though, is by using a bot again. To get some level of consistency across all of this, we don't want people just clicking on the GitHub UI and typing in uncontrolled text. So we've set up a set of bot commands that make it easy. You say /sig space the name of a SIG, and it will apply that label or tell you that it doesn't exist, ideally. And that helps us get some of that consistency up front. And there's an example. This is just a comment in Git. And then the other nice thing that this does is it gives sort of a track record. If you're looking on GitHub and somebody's made changes through the UI to the state of an issue or a PR, you can't really see how or when that happened. But when you do it in the comment flow, it preserves sort of a history of how and why something happened. So maybe multiple people have triaged an issue. The first person says, it's SIG cluster lifecycle because I was upgrading my cluster and upgrade didn't fail. So you blame it on the people that do upgrade. They triage the issue and say, oh, the cluster didn't upgrade because of a networking failure, and they assign it to SIG networking. When you do that in the GitHub flow of comments, anybody can see this. And instead of the networking person just doing a really trivial triage of the issue and saying, oh, this is an upgrade issue, and assigning it to SIG cluster lifecycle, you see that they've already dealt with it and looked at it and are passing it on to you. So again, at a human level, this is about making sure that the interactions have less friction, because you've got 2,000 people, you've got every time zone on the planet covered, and you have to be able to collaborate. So having a persistent little cookie crumbs of what's been going on in the Git history or the GitHub comment history is really, really important. So the kind label, I mentioned kind bug or kind feature, but there's also kind documentation, design, failing test, flake. That's for flaky tests. It's not just outright failing test, but it's a wobbly test. Kind cleanup, there's a whole bunch of them. And again, you just say /kind and the kind that you want to assign. And this is really useful for triage if somebody is trying to figure out, I mean, maybe you already understand that it's a failing test, or there's actually automation now that notices failing tests and creates the bugs, labels them a failing test, and then somebody who wants to help improve tests can go find all the currently failing tests. Again, just getting humans oriented towards the project in a more efficient way. Priority. This can be a tricky one. This is not required because it's a little bit more subjective. But at some point, maybe as a SIG's leadership has triaged a bug, they'll decide like, oh, this is a really big deal, or we're gonna put this on the backlog, or somewhere in between, and they'll apply this label. And again, this is a sign for the humans. If you're someone new coming to the project, you may wanna start out by looking at the backlog. Where's something that's just kind of sitting there that I could kind of dabble at for a bit and get some orientation? But then also be giving real value to the project still, because it's sitting there, somebody wants to see it happen. Area. Gwen talked about SIGs and subprojects and work groups and all these different things. These are labels that kind of get at that, a little bit finer grain than just the SIG. And there's a ton of them. These are just a few examples. There's a set of triage labels, and these have sort of come and gone a bit in terms of their popularity or usage, but we're trying to make it more apparent out of the set of 2,000 open issues. Has somebody looked at this? Or is it a duplicate of another one? Do we need information from the reporter? Is it a support question? We don't use Git or GitHub to answer support questions. We redirect people to Stack Overflow or Discourse or Slack. Or did somebody actually triage the problem, couldn't reproduce it? All of this is about leaving cookie crumbs of what has happened for triage at the given point. And that is my last one on issues. And want to spend a period of time now just talking really generically about open source. So I'd mentioned that I've been doing open source for pretty much my whole career. Who here has been solely a proprietary software developer? And who here has sort of been a mix of proprietary and open source? And who here has just been pure open source? Yeah, it's a little bit more rare place to be. He's got jet lag. He raised his hand twice. I think on average for most people, open source and open source interactions it's either a new area to explore and learn about, or it's something that you've started getting into, but maybe at times becomes daunting because it's a different way of doing things. And I've interacted a lot in my career with proprietary developers and have been sort of on the side of a lot of proprietary development, even though I've been working in open source. And I feel like at times proprietary development or smaller products inside companies where you have a tight timeline, it's really easy to kind of get focused on implementation and a centralized way of doing it. And you've got assumptions within the team, all sorts of things that are implicit to the small core set of people. And then I would sort of summarize that as like a me mindset. In open source, you have to figure out how to get to the we before me. And collaboration at scale with 2,000 other, or if you look at 2,000 active, for some fuzzy definition of active, 2,000 active contributors on Kubernetes or more, you can't have implicit assumptions. You have to figure out how to get at a shared theory of a design intent and be very explicit about it, and then do that in a decentralized way. You can't just bring everybody into a small room and on the whiteboard draw something, it's in their head, and you go away. You have to record this into durable artifacts in a way that are shared and visible on the internet. And that really, to me, is then the essence of collaboration. Open source isn't just about having access to the source code. If you look at the OSI, the Open Source Initiative, their definition of open source, they have 10 bullet points around what is open source. And a couple of those relate to you must be willing to accept collaboration. People have to be able to change your code, and it's not just a one-way street. And this also, I think, a pattern that you might get into is a proprietary developer, or even just as a simple developer, is like, it's about the code. I'm just focused on the code and functionality. I just want to get this done. But really, like what Gwen said earlier, there's a lot more to things than that. We don't just have functionality SIGs in Kubernetes. We have all sorts of broader and sort of meta-related SIGs. There's documentation, tests. You have to be able to integrate your code and functionality with others. It's not just writing a piece of code, publishing an API. Somebody's going to use your API, and it's not going to work the way they expect it. And you have to figure out some common ground there if you're going to actually collaborate. It's not just telling them, well, you're doing it wrong. There's all sorts of things you need to do around release management and a release cadence and processes there so that you have stable releases, stable expectations on your users. And you have to think about security. And there's all these things that are sort of a much bigger picture. And as you interact with them, it makes for a lot more human and social interaction than you might have in other styles of development. And I really passionately believe that if you can master this bigger picture and doing it collaboratively with other people in open source, it makes you a much better engineer. It's also a good point then, kind of talking about these human and social interactions, to remind you to be good people. And we have a code of conduct on the project. I think Gwen mentioned it at the beginning. If you're going to have this level of collaboration, it's basically mandatory. It's a prerequisite that you have mutual respect and treat others well. So keep that in mind. Okay, so open source. Your first goal is like, I'm coming in, I want to make a commit in the project, I've got this idea, I want to PR it. So that's your goal. How do I get this change into a project? In a proprietary world, maybe you talk to your PM or your coworkers, you describe it, whatever, you make it happen, they see it and they accept it. Open source does not work that way. So you need to be thinking about visibility and transparency and proactive communication. You have an idea in your head, you need to figure out how to share that with other people. And you do that not just by sharing the code. You don't just show up with a PR, ideally, but you also have documentation around your code and test cases around your code. And maybe you've shown up to all of those things that Gwen talked about earlier, the Zoom meetings, the Slack channels, you're on the mailing list. People, when they see PR by Tim Pepper, they have some sense of, oh, that person, they just started, but they've been around, they've been asking questions. I'll take a look at it, I'll interact with them on it. And that interaction then is getting somebody to review your code. And what does reviewable code mean? It's not just that you made a PR and your code is visible on GitHub. You have to demonstrate that you have a sound idea, and you do that through words. If you're making the reviewer's job easier, you're not just sticking some code there, but you have a pull request with a description. You have commit messages that are descriptive, and this is through natural language. And within that, you're wanting to demonstrate that you've got architecture, that this isn't just some random one-off. A reviewer, if they don't understand your idea, what you're trying to accomplish in the first place, they're gonna stop reviewing your code and say, like, I don't get what you're trying to do here. And if you thought you had something simple and obvious, but the reviewer's on the other side of the world and they come back to you, suddenly it's been 48 hours since simple and obvious, and all of this can really bog down the collaboration or how you get to getting your code merged. So you should think about all of this up front so that you kind of reduce that friction and make things happen faster. Ideally, the reviewer doesn't start with the bottom bullet of polished implementation, that they don't just look and be like, oh, you use spaces instead of tabs and stop. Like, that's not a positive, constructive open source collaboration. It can happen. I won't say that it doesn't. But hopefully, if you've shown that you have a sound idea and good architecture, they're looking to see, does your code implement the idea that you articulated, and is it architected as described, as opposed to just being like, I don't get what this is, plus the coding style is weird, or it doesn't meet whatever the standards of the project are, and just sort of shutting down and not paying attention to you. If you do your homework ahead of time and try to address these types of bullets, the reviewer is going to have an easier time with your code. The most important thing for somebody new to open source, I think, is to go to this URL. Chris Beams, he has a blog post on how to write a good commit message. And there's a set of bullet points there. I think, do I have this on the next slide? Yeah. So all this is about making the reviewer's job easier, but read Chris's blog post, and he's got a whole set of things that you should do there. There's 7 particular points. But within those, there's kind of 2 meta summary ones that I describe to people. One is use the subject line of the git commit message to just summarize what it is you're trying to accomplish. And then in the body, always have a body on your git commit message and use it to explain what and why you're trying to accomplish. Not how. The code is how you're accomplishing something. But use this space to say, in the summary, bug fix for such and such problem, so that somebody maybe can orient initially and then go read the details, describe the problem, describe how you're going to fix it, and then leave the details to the code. But if you give that little bit of orientation in natural language, the reviewer can look at your code and know what they're looking for, instead of having to read the code and reverse engineer your design. If the reviewer is busy, they're not going to have a lot of time to do that type of reverse engineering of your own code just to review it and see if it does what it's supposed to do. So give them the information up front. Timing. I talked about already kind of the slowness. If you don't do some of these things up front, then the interactions back and forth start to span days or weeks. But it's important for people to realize in open source that if you actually care about this stuff and others in the community care too, it's not just submit a PR and merge it. There's care and thought that follows. And that takes time. And it's a trade-off between quality and speed. And ideally, we all want quality, even though only half of you raised your hand when you said you were going to test your code. Hopefully, we all care about quality. And then it is decentralized. It spans the world. And where it's something more complicated, like hopefully you don't try to show up with this huge 200,000 line commit that does this massive feature, because maybe that generates a massive amount of conversation. If you're doing something really big and you need to advocate for why it's important, then that advocacy is going to take time. You've got people all over the world with different mindsets, and decentralized consensus making is hard. It takes a lot of time. There are some things that I'm trying to accomplish on the project that I think ultimately will be relatively simple. The code will be fairly small. All told, it will maybe be a few person months of work at the most. But it's taken a year of conversation to start getting some alignment on why it's necessary to accept those changes. So anything that you care about can take a long time. In aggregate, open source moves really fast. And a lot of time can mean anywhere from as much as 9 months to 2 years to go from a basic idea to something that's considered stable GA. And the reason for that is that we have a development cycle. And any open source project has something for a cycle, and it's important to kind of do a little bit of homework and understand those things up front. So on Kubernetes, we have 4 releases a year, so the release takes 3 months. During that time, there's a period of code freeze. So if you come along, and it starts next week. So if you come out of here really excited, you've got some idea, you've hacked around for some cool little extension or fix or something, and you throw it out there, people probably aren't going to review it because it's code freeze time and they aren't going to be able to merge it anyway. So you get these periods where you don't have velocity on the project because there's some stabilization going on. So you need to be mindful of that, and it's okay. And hopefully your reviewers or somebody will will see your pull request or your issue or your attempt at conversation and say, hey, we're really busy this week, but first week of July, we'll be all over this because we'll have finished the release and we'll be starting the next one. So you get sort of this cadence of things. And it can trip you up, especially if you're here because your boss told you got to get this feature into Kubernetes. Well, you got to understand the timeline and when and how to slot major changes in. So if you have an idea, over the course of that release cycle, over the course of the months, you get something in, and it goes out in a Kubernetes release. In its initial state, it's considered alpha. And things have to be in at least one release, which again is another 3 months before they can graduate to beta. Things have to be at a beta state in at least one release, which again, another 3 months before they can graduate to stable. So that's where you get that elongation of time. But this again is part of the consensus process and making sure that we have something over time that's well supportable. We don't want to just rush forward and have something that we call a stable API that we then have to support for a couple of years when immediately everybody who's using it wants to change it. So we try to have this process be an actual alpha where you get people using it and some brainstorming and collaboration and expand the API or the usage scenario, really solidify it for the set of stakeholders that you have. At the point of beta, APIs are supposed to be stable so that people can use them more and really validate them and root out all the bugs. And then obviously stable, we're trying to keep it well supported. Now, within this, there's a couple of things I want to talk about that are specific to Kubernetes and the way it works. One is that if you have an enhancement idea, you need to socialize it. And this is general open source. But once you've kind of done maybe just a very superficial socialization of an idea, we have a thing called a Kubernetes enhancement proposal, or a Kubernetes enhancement process, KEP for short, K-E-P. If you've seen Python PEPs, Python enhancement proposals, it's a similar sort of idea, or OpenStack has blueprints. So this is, again, around consensus forming and creating durable artifacts for collaboration. You've got an idea, but getting it out of just your head into a document that describes the detailed intent of the design and a bit of maybe implementation details, shows what your plan is for upgrade, how you're going to manage your API mutations if you need to do something like that, how you're going to test it, that you have a test and documentation plan, and then getting that reviewed, because we don't want people to go off, especially as the project's growing, we have lots of newcomers and people looking to do bigger new features maybe specific to some cloud or some particular thing. We don't want you to all waste your time going off in some direction that maybe doesn't end up aligned with the bigger project. So by getting this upfront documentation allows us to all really align on things. One thing I also want to say within this is that this is explicitly not, hey, come focus on simple things, just do bug fixes or documentation for your first year or two until you get known and can advocate something. I've been on open source projects where they explicitly said that. You'll never be able to do anything in this project until you establish yourself, and that's going to take years of doing silly, trivial stuff. And we want anybody who's a skilled engineer to be able to show up and deliver value in the project. But we also need the project to mean something. So we need you to understand what it is that Kubernetes is and how and why we do things, and to build consensus across all the different people here too, so that you're not pulling the project in one direction and somebody pulling it in a contradictory direction, that when we see similar people doing similar things, like cluster provisioning, that at some point we say, hey, let's have a cluster API. Let's get all of the cloud providers thinking about how to do this in a common way. And ultimately, that makes the project stronger when we do that. But it means that, yes, for something that you care about, it's going to take more time potentially. You may have an idea of an extension you want to make, but it becomes harder in the broader context of all of this open source stuff. You can't just make a trivial implementation because the community wants a quality one that everybody's going to be able to use and contribute to. Again, I think this is a skill that if you learn it, it makes you a stronger engineer, a stronger software engineer, being able to advocate for your change, being able to up-level and understand and abstract where necessary. Okay, so abstract open source. But what about some specifics on Kubernetes? So I'd mentioned GitHub pull request workflow. Who is comfortable here with this? I think there were a few hands who were maybe not. So who's comfortable? Uncomfortable? Kind of. Okay. So as you do things more in the community of Kubernetes, you'll go through this life cycle a lot. I talked earlier about how you have the main repository, github.com/Kubernetes, but you fork it into your own version of it, and you're creating pull requests. As you're doing development yourself, what this means is you've got your own master branch that you're pushing to or pulling things from, but you also have the upstream Kubernetes, and you'll have to periodically fetch from there and rebase your changes on top of that. This can be tricky when you're new to Git and GitHub, but again, I would say ask for help. Your pull request is just kind of the basic currency of how you collaborate at a code level. But there's a Kubernetes workflow as well. The simple GitHub workflow is you make a PR and something happens. Somebody presses a button on the GitHub UI to allow your PR to get merged. Because this is such a huge project and we have thousands of active contributors, we can't just have a limited number of people who have that big green button on GitHub that says merge, because that would be a bottleneck. But we also don't want to have thousands of people, because then what's the quality criteria? Bart's a very rigorous reviewer, or Lubomir is a very rigorous reviewer, and maybe I'm a really sloppy one, but I'm the one merging all of this stuff. Like, that hurts the project if that happens, right? So kind of becoming hopefully more best practice nowadays is that you have CI, continuous integration, and you have ways of establishing in an automated way what your quality criteria is. So in addition to all of the bot-related labels, as things work through the state of validation, at the point that all of the tests pass in Kubernetes, automation will actually just merge the code. There's very few people anymore. I think there's maybe 12 of us or so who have the GitHub merge button that we can press, because we don't want humans doing that, because it makes things more arbitrary if so. So in Kubernetes, you submit a pull request, you add those required labels, you make sure your Git commit messages are good, or your PR is well descriptive, and then the bot is going to validate the state of things. It's going to look at your code, and it's going to look at your PR, and it's going to decide whether you need a release note or not. It's going to see if you are a member of the community or if you still need to sign the CLA. It's going to decide whether it's okay to run this code for the first time in CI. Because if we allowed, the same as random people getting on Discourse, and all of you starting on Discourse needed approval because we have spammers, GitHub's a great place to be the equivalent of a spammer. If you come along and say, hey, great, they've got these big clusters, like your PR is going to get tested on maybe a 100 node synthetic Kubernetes cluster. That'd be a great place to maybe mine some Bitcoin. So I'll make a PR that's a Bitcoin miner. We can't allow that. So unless we have some level of trust established, your code will start out with this needs okay to test label. And until you get that, your code won't get tested, which means it can't get merged. Kind and SIG I talked about. But as a newcomer, your first pass ones are going to be CLA, okay to test, kind and SIG, and whether or not it deserves a release note. So you start to iterate at this point. The bot tells you things, you react to them, you add more information, you add more labels. And you start looking for people to review and approve your code. To get it merged, you need somebody who's an owner, and I'll go into more detail on that. We need them to apply the approved label through the approve command. And then anybody on the project who's a member can apply the LGTM, or looks good to me, label that implies that they have reviewed it. So any code that matches all of the label requirements around having been reviewed and approved and have release notes if needed, and has had testing and the tests pass, when all of those quality criteria are met on an automated basis, we have a thing called Tide that will actually merge them in. And this is, the goal here is to have a consistent automated quality process. And again, I think this is becoming hopefully best practice in industry, software engineering, DevOps, GitOps is all about this, but it varies. So a few other commands that you can do, if you know somebody in particular should be the reviewer of your code, you can comment with /assign and their GitHub username, and it will assign the PR to them for review. If, or rather when, tests fail, you can do /retest, and any of the failed tests will get rerun. And sadly, I say when because we do have a lot of flaky tests, and there are a lot of tests that will get run automatically on PRs. And depending on the state of test infrastructure, test case code, or the master branch in general, because you're making a pull request against the master branch, well, somebody else may have just managed to merge a commit that somehow introduced some problem, and your PR may not pass tests. As an example, I know Lubomir had this problem when he first joined the project, and I definitely did as well. I found somewhere in the code a comment that was completely wrong, and it referenced a website for more information, completely wrong, but I was able to Google search, find it, and find the right information. So I was like, well, I'll just PR this fix so that anybody else who stumbles on this later won't have it. So this is a non-functional code, it's in comment, it's updating an URL. It didn't pass CI. And it turns out it was because of a flaky test, and it was a known problem that day, and somebody fixed it. But this pattern happens over and over again. So as a newcomer, it can feel daunting. You pick out something simple, hopefully, to start with, hoping that you'll have success, but you run into the test failures. So know that they're not as great a quality as we would all like, especially if you have DevOps or test experience, and that's a passion of yours. Someday I would love to see you contributing in those areas because it's something that we all need to be contributing more to improve. There's a close command to close the PR if you decide like this wasn't right for some reason or somebody has basically argued for why you needed to go about it completely different. You can just close it and come back later with a different, better PR. You can also do a CC in a GitHub username just to sort of try to notify somebody that, hey, this might be of interest to you. The problem with CC, and also to some extent with assign, is that the people you may want to look at your code or think are the most appropriate, they're the people everybody wants to look at their code. So if I do this example, if I go to, so when you're doing simple things at first on GitHub, if I can get out of full screen. There we are. When you're doing simple things on GitHub, you may be used to collaborating through GitHub. And part of the way that you do that might be this little icon up here, the little bell telling you that a notification that somebody's commented on your pull request or commented on your issue. And if you're in a small team, this can be effective because you're working asynchronously. When you get onto a big project like Kubernetes, I have 10,000 unread notifications on GitHub right now. At some point, it just falls apart. And this is the story for basically all of us. So understand that there's humans on the other end of the computer, and you're trying to get their attention, but a lot of other things are. Between the robots and the failing tests and the other humans, it can be very tricky. And this is where Slack and mailing lists and other things and the Zoom meetings are a totally effective additional ways to try to get attention. If you're doing something big, I'd really recommend showing up at a Zoom meeting, asking for a couple minutes on the agenda to just describe this big thing, this big idea, because usually your big idea, once you share it with others and get broader context, there's going to be lots of other things that need considered, and you got to talk through those. All right. Okay. So, reviewers and approvers in a little more detail. So that first pass thing of putting a SIG label is the number one thing you can do on a PR, because it's the way of that first order way of getting on the sort of to-do list for the people in the SIG, and those are going to be the most applicable reviewers. Ideally, that should happen automatically because when you look at code, SIGs are about owning code, and you can map, generally, a code change to who should be the owning SIG. That may not happen completely automatically, correctly. There may be other SIGs who have an interest in your code, so validating what the state of the SIG label on your PR is going to be useful, because then you show up on people's to-do list. If a SIG is triaging their current pull requests, you want to be on that list. If you have a mentor, somebody that you're working with in the community, ask them for a little bit of help. If your PR seems stalled out, ask them what you should do next. Consider people like me as a potential mentor. Feel free to reach out on Slack and ask for help. It's not the most scalable, but since there's sort of a limited number of people here, like for the next few weeks, you have my attention because you're newcomers, and I value that. Also, contacting the SIG, like I said, go to the meeting, go to the SIG Slack channel, send an email to the list. Now, you don't want to be like, you want to be persistent so that you don't just get forgotten, but you don't want to be a mosquito buzzing in the ear of people either. So submit your PR, give it a little bit of time. It may take a few hours or a day or two, but if it's been a week and nobody's noticed, definitely start asking around and trying to see what help you can get. And then contact owners. And this is not the next slide. I will go into owners in more detail, what that means specifically. And there's a mechanical way to do it. By default, when you make a PR, automatically it's going to be assigned, hopefully, to somebody to review it. But that somebody is pulled from a list of people, and it may not have been the best person. The automation can't know that our node is at Kubecon right now and probably not reviewing a bunch of code or things like that. So an automatically assigned person may not be the best person, and if it's been stalled a bit, you could maybe look at other potential owners, and I'll get into that in a little bit more concrete detail, hopefully. And I lost my speaker notes, and I need to get them back, because I think there was something else I wanted to say here. Oh yeah, I have a million notes on that slide. Let's see. Yeah, I think I hit most of what I needed to there. Yeah, again, just that idea of being patient. Like, you want to be persistent, you have work to do, and you matter. You shouldn't just be sort of sitting there in the void, like saying, hey, I have some code here, I want to help. Like, we should be responsive to you, but everybody's busy, and you don't want to be a spammer just like 3 seconds after opening a PR, emailing 5,000 people saying, hey, why haven't you reviewed my code? And there in Slack, I'm pretty sure it's disabled, the @ here or the @ channel, because there are like 60,000 people on the Kubernetes Slack. And depending on the channel you're in, you may have 4,000 or 5,000 people, or all the way up to all of those 60,000 people. And you don't want 60,000 people in the world to pull out their phone because it just buzzed, because you want somebody to look at your PR that you made a few seconds ago. So you individually have to understand how to behave professionally relative to the others, but know that you matter, and don't just sit there quietly. Don't suffer alone. So I've talked a bit about the robot, and I showed a screen cap earlier from the robot. This is quite possibly one of the most frequent things you'll see from the robot. After it's told you, as soon as you open the PR, that you have you need to apply certain labels, or that somebody's been assigned to do a review, tests are going to start running. And these tests could take a half hour, an hour, depending on what all is going on, because they're running on shared cloud infrastructure, and eventually something is potentially going to fail. But I want you all to start out with the base understanding that the bot's trying to tell you important things. You'll see all sorts of bot comments, and it might be easy to just sort of skim over them and not really think about them, but you need to actually think about them. So if you get a message like this, your commit may have actually broken Kubernetes in these scenarios. And in this screen capture, there's a commit there. That's the one that's one of the ones in this particular PR. That's probably more for somebody else who's going to be reviewing your code, trying to understand why would that have broken this test. But the column there that's the details link, I feel like that's really for you to click on. You need to go look at that. You're going to get the details of that test run, and you need to try to understand, what did I break? Do that also while knowing that some of these are typically flaky tests. If you pull up that link, and there might be 5 or 60,000 lines of test output, but the automation there will have whittled it down and be highlighting just a particular set of failure regular expression matching lines. You can expand and get the others, but the failure stuff, the automation will try to highlight. If you look at that and it just says sort of timeout this, timeout that, probably something somewhere else has broken, where a test automation that didn't have a tight synchronization point was waiting for something to happen, and it was slow for some reason and didn't arrive in time, and the test was just flaky because of that. There's a lot of effort underway to improve the tests that have that failure pattern, but it's one that you will encounter all the time, and especially some of the bigger tests that are longer running. The longer a test runs, the more likely statistically that something is going to go wrong. But you'll see that very quickly. You click on that link and you see just some simple timeouts. Say retest, and odds are it will succeed. You may at times feel like you're rolling the dice on some of these CI tests where you just retest, and you're just hoping for a green run. Sadly, that is sometimes the reality. We're trying to improve this, but know that that is normal. Normal bad, but it's something that we all are dealing with now. This kind of goes back to the section on general open source engagements. It's on you to answer your reviewers' questions. Now, the very first reviewer is the bot. The bot's going to tell you certain mandatory things that you must do for your PR to merge. You need to do those. But also, if somebody is looking at your code and commenting on it, be responsive. Again, there's no SLA here. It's just like your reviewers may be busy, you may be busy, but if somebody's made a comment on your code and after a couple of days you haven't at least said, oh wow, I never thought of that, it's going to take some big restructuring on the code, but I'm going to do it. The reviewers and others don't know it, and they start to get a poor impression of you and your engagement. So just like you would expect them to be professional towards you, try to be professional back. But then definitely do the things they say, or at least have a conversation. If somebody who owns and is responsible for the quality of some code that you're trying to change has an issue with your implementation, you need to figure out how to resolve that issue through conversation with them, through changing your code potentially, whatever that path is. That is your job in open source, to find that path. And then obviously test failures. The automation doesn't allow us to merge code that has test failures, so you have to figure that out. Maybe it's just flaky tests, you roll the dice, eventually you pass, but if you've truly broken something, you need to fix it. With respect to reviewers and comments, also kind of in the abstract open source, know that different reviewers have different opinions, and across thousands of stakeholders in this particular project, you may get conflicting reviews. One person may be telling you one thing, somebody else may be telling you something else. It's, again, on you to figure out a way to bridge these things, figure out and drive consensus so that you can move the thing forward. And don't overreact. Somebody may have a very negative response or also a very ecstatic response to your code, but that doesn't mean everybody's going to, and know that just because one person really liked it or didn't, that doesn't mean your code is completely wrong or completely successful. There's a fuzziness here, and you have to figure out how to bring the different opinions of different reviewers together to kind of collaboratively move the state of things forward. The contributor ladder. Gwen talked a little bit about membership, so like who wants to be a member of SIG architecture? That sounds daunting. You're going to be on the architectural review panel for the Kubernetes project. No, it's just, that means you've joined a mailing list. And that kind of ripples across the whole project. Anybody can make a PR on GitHub against the project. You'll get the labels that say that you need to sign the CLA. You'll get the label not okay to test because you're new and you're not trusted. But if you've been minimally present and engaged in the project, you've made a couple PRs, you've talked on some issue threads, or you've been around a little bit minimally collaborative and have a track record that's even just a couple of things that show goodwill and presence, you can become a member of the org. And that gets your GitHub handle basically added to a YAML file that says, like, you're cool, you're okay, you're not a Bitcoin miner. And that is the first level of being a contributor on the project. And it basically means you got a couple people who are willing to sponsor you, you've shown this little track record, and in return, you get your code automatically run through CI, so your PR cycle is faster. The next level from there is to become a reviewer. There you have much more history in the project. Again, maybe not huge history, but you've been present. I was talking to somebody last night where a new person had come around and they seemed like a solid engineer, and they were starting to review more code. It wasn't their job or their title as a reviewer in the project, but they'd been reviewing code. So they chatted with them and said, hey, if you're doing this, why don't we make you a reviewer? We'll put you in the YAML file that says you're a reviewer, and you get a little bit more privilege, or your LGTM on an issue means a little bit more because of that. So that was, they'd been around for a couple of months. So the hurdle here, it's not just a couple PRs or a couple comments and things showing that you're not a Bitcoin miner, but that level of interaction. So within a few months, potentially, you might be able to achieve that reviewer level, or maybe it takes a year or two of really getting involved, somewhere in that range. The next level up is approver. This is harder to attain, definitely, I mean, a year or more potentially to get to approver level where you've really been active, because this is the point where when you apply the approve label on a PR, it's going to be able to merge, assuming it passed tests. So there's an expect that you're doing really quality reviews in more detail, you understand the broader context, you're giving a little bit more thorough analysis to what the PR means to the project in the bigger picture. And then the top level of owner, you're more of a lead engineer, I guess, at that point. You're helping establish the direction of a SIG, and that's going to take time to get to that level in the project and being particularly deep into a particular technology. So people will talk about the contributor level, about reviewer or approver rights, things like that, and that's basically what it means. As newcomers, your goal should be to become a member. Be present, be active on GitHub to the extent that you can, reviewing code, commenting on code, opening issues, helping debug failures, making some first initial PRs. Any of those sorts of things can get you to become a member and be a valued part of the community formally. And then you get that $1,000 patch that Gwen showed, the contributor logo patch. This is an example pulled from GitHub of what happens when you're not a member. You make that first PR. It's afraid you're a Bitcoin miner. Applies the need OK to test. So you all can expect to see this at first, and you'll need to get somebody to do that first minimal review to apply OK to test so that you can get run through CI. Once you're a member, that goes away. And it just makes your workflow a little bit faster. All right, more information is available on the web. There's a whole web page talking about the membership. And then just a quick screen cap from it, kind of summarizing those things, and it's flipped upside down. But a member is just saying that you're kind of active in the community. For a simple, lightweight definition of active, and reviewer and approver and owner are just kind of iterative hurdles or recognitions above and beyond that. Okay, owners files. I kept saying I was going to talk more about owners files. So here I'm going to jump onto the web. So owners files are, or owners in the plain English sense of owners, ownership, people who are responsible for code. This is actually articulated in the code itself. If you're in any given subdirectory, there might be a file called owners. And if you look at it, it actually says who it is that's responsible for that stuff. So we have, just as a little plug here, we have a contributor guide. That's the link to it. And within the contributor's guide, it talks about owners files. So you can read this and learn more about the details, but it's basically giving you a sense of the schema of that. But as an example, if I go into the directory for the contributor's guide, we've got all these bits of markdown that represent the guide, and then there's an owners file. And in here we have reviewers and approvers, and these are their GitHub names. So for example, myself and Gwen, we are people who review contributor guide contributions. And Gwen is actually one of the approvers. So she's kind of, and here also you sort of see the hierarchy. You have lots of members, there's hundreds of people who've contributed to the guide. There's 6 people who are tasked with reviewing changes to those guides, and 3 people with the ultimate say on whether the change goes in. And these are all over the place. If I go back just into the Kubernetes, I'm in the Kubernetes repository. And linked there was the owners file for it. This is hierarchical, so if you're out in some Leaf directory, there's an owners file there that covers the stuff there. But as the automation walks up the tree trying to find reviewers and approvers for your code, this is sort of the default last case. And not too surprisingly, at the very top, you see people like Brendan Burns, Joe Beta, Tim Hawken, who are like original Kubernetes people, but there are a few others, and approvers list is a little bit longer. But if you're having to call out to these people, they're going to be the most busy people. As you're looking to try to figure out who could do some reviewing on your code, you really want to be down in a leaf node of the tree. So I talked about like kubectl. If we were making a change to the apply parser, there's no owners file there. Okay, so who's in charge of apply? There's no owner there. Okay, kubectl, there's definitely owners here. And the bot's going to do the same workflow here. It's going to have gone through that. And it says that the reviewers and approvers aren't a GitHub handle. And what this means is there's a group, a GitHub team. And if you go look at the GitHub Teams UI, why did it do that? All right, if I'm at the org, and if you're a member, because these are mostly private, I'm not sure if any are public, you can go into Teams, and so for example there, it said SIG-CLI. I can do a search and I can find, we've got SIG-CLI, API reviewers, or PR reviewers. And this is where the mapping happens to GitHub names. And there's it's not loading them all, probably big list. Oh no, it's a short list, I guess. Oh no, wrong tab, members. 21 members of reviewers there. So these are the people that you would want to talk to. So when you submit a PR, the bot's going to automatically assign a person, but as you're looking for broader review and approval, you might need to similarly jump off through the owner's files to find a GitHub team and find some people to talk to. But this is actually like, it's a bit of indirection, or maybe feels again as something sort of daunting, but these are like actually human faces, or human names, hopefully, and they're people that you can see on Slack. So if you're in the SIG CLI channel and Jordan Liggett or Phil Whitrock is talking about something and you know that they're one of these people and you see them active on Slack, you could sort of say, hey, I've been struggling on a PR. You have a moment to answer a question. And you can make a more one-on-one connection and get a little bit of feedback and interaction. And people are generally open and friendly on that sort of stuff. All right, so now it's your turn. So this URL here, if you can all type into that and open it up, what we want to do for the next bit is for kind of the next 10 minutes or so, just go through playing around on GitHub and have you all try to make some PRs. And we'll work through a number of things by doing that. Sorry, I hid the URL from you, huh? There we are. Okay, so sigs.k8s.io/contributor-playground. And that is a link redirection. It's going to take you to a particular GitHub repo. So you should be coming up at GitHub, the Kubernetes-sigs org in the contributor playground repository under that. And there's a subdirectory called Barcelona. So what I want folks to do in the room is to clone this repository, well, fork and clone the repository, and try to make a PR against it. So start out just by making maybe an addition to the README, like a hello or something like that. And what you'll need to do is find an owner in order to get them to approve the PR. So we want to have a set of pull requests come in from you, the audience, and we're going to try to actually get them into the repository right now. And I am going to start with a first PR. Do you have your laptop, Lubomir? Yeah. Okay, well, I'm going to add you to the owner's file. So I'm going to work through on the screen of making a change, doing the same thing. So I'm going to get the repository, I'm going to make a change to the owner's file and PR it so that we get one other volunteer in the room who's able to do PR handling as well. So the first thing you would do is you'd fork the repository. Or actually, you know, we don't have to do that in this case. You can just straight clone it, I think, and PR directly to it, I think, or what do we have to, you do have to fork it and PR from your, yeah. Yeah. So I fork it, GitHub asked me where I'm making the fork. I've already got one, perfect. Okay, so I have my contributor playground stuff checked out. And again, this is doing the same thing where you've got an upstream and your own sort of repository. If you're not comfortable with that, raise your hand and we can get a volunteer to help you. And I'm doing a rebase of my master branch to upstream's master branch. I'm going into the Barcelona directory, and I'm going to add Lubomir, who's neolit123 on GitHub, to the reviewers, and why not the approvers also?
I can also use my phone, I guess.
Yeah, that's true, yeah. Okay. And then I need to commit that. And I'm going to model good commit hygiene, hopefully.
And are we going to have a lunch break?
Yes, in just a couple minutes. We are, where is, lunch is at 1 o'clock, so we have 2 minutes. So after lunch, we'll fiddle around with this just a little bit more.
So you want me to do GTM by OPF?
Yeah. So I am pushing that commit.
Is that direct pushing to master?
No, it's pushing. So if I've set up, what I did was I cloned my fork of the repository, and the origin is github.com/tpepper, me/contributor playground. I have a remote for upstream, which is the Kubernetes one. So if I look here, if I change the URL from Kubernetes SIG's contributor playground to tpepper playground, the most recent commit there is mine. And GitHub is telling me this branch is one commit ahead of Kubernetes SIG's master branch. And I can click on the pull request link there, and it creates a pull request for me against the master branch, the upstream master branch. So when I create that,
I guess using the master branch of your fork is still not.
that's true. Depending on your workflow, it would probably be better for you not to work on your master, but you create a branch and you push. It all depends on how forked you want your development to be. Good hygiene, you would not work on master of your fork either, probably, but that's a development practice. So now if I'm on the Kubernetes SIG playground, my PR shows up there. It says tpepper master branch is the source of a PR for Kubernetes SIG's master branch. And the bot here is telling me immediately, there's a pull request approved by tpepper. It noticed that I was in the approvers file, so it automatically approves of this commit. I philosophically have a slight hang up with this. I may be making a PR for reasons that I like, hey, here's some code, let's talk about it. But it assumes that if I'm to the point of making a PR that I must approve of my own work. It's fuzzy. It won't merge because if I scroll down a little bit further, the bot's telling me Tide says that this PR is pending, it's not mergeable because it needs an LGTM label. So I need, even though I'm an approver, my code doesn't automatically flow in with an implicit approval until somebody else has reviewed it. This is fuzzy if you're doing some sort of work in progress thing. So for example, if I were to edit this and put a little work in progress designator in the front of it, the bot has reacted and it added a label here. Do not merge, work in progress. So as an approver, this is sometimes a workflow that you'll see people do. They'll make their PR, but then mark it work in progress so it gets more review. And when I save it, having taken that away, the bot again notices and says, no longer work in progress. So it's lunchtime, and I see that there are a ton of new PRs here. Of the ones on the top of the list here, Zoro Wang, Akko 50, Mickey Boxel, those Are you in this room or is that the other room doing this in parallel to us? You're here? Cool. Awesome. So some of us who are the reviewers and approvers will go ahead and approve those, but I want to see folks maybe across the course of lunch if you have a few minutes to try this out. And if you have trouble, let us know. But we'll go ahead and break for lunch.